Alright, so number 40, to graph this without a graphing calculator, here, let's get this out of here. Basically, what I would look at first is a couple things, like where is this thing going to cross the x-axis? Okay, so if I was to draw a coordinate plane, where are my x-intercepts going to be? Okay, well, first off, as my voice cracks again, I could look at this and say, dude, I could factor out an x, and if I factor out, let's take a negative x. If I factor out a negative x, well, they even have x squared, then I would have x minus 1, right? So if I was to factor this, it would look like this. So now to find the solutions, we take, well, the opposite of this, so that means x equals 1, and then this one's just going to be x equals 0. So at 0 and at 1, this is where it's going to be crossing the x-axis. Does that make sense? Okay. Now, since it's a cube function, remember that's going to be the negative disco kind of going like this, right?
Oh, so I was graphing it.
Okay.
I graphed it, but it just wasn't looking right. So I was like, what the heck?
Okay, good. Thanks for adding that to my presentation here that I'm recording.
Oh, it's recording? Sorry.
So anyways, it's going to be coming down like this because it's negative, and it's going to somehow be crossing through here. So all I would do if I'm taking a multiple choice test is I would just find these x-intercepts first, and then whatever the graph looks like, just use a t-chart. Okay, let's see what it looks like at negative 1. So if you put negative 1 in, negative 1 squared is or cubed is negative 1, so that's going to be positive 1, and then this will be positive 1 as well. So at negative 1, it's at 2. Okay, so that means that this thing is going like this. Kind of makes sense?
Yes.
Okay, so then yeah, I think you would just go with it from that. Okay, and that's going to be the way. Like, watch. Let's try what 3 is maybe.
I did it already. 3 is no, I did 2.
Well, 2 is 0, right?
2 is negative 4.
Oh, 2. Oh yeah, that's right. 2. 2 is negative 4. So 1, 2, 3, 4. All right. So 2 is down here. So you see that from here to here, it's kind of going down. So that means somewhere in between, there's going to be either a wiggle somewhere, but it's going to somehow connect, and the graph is going to be like it could go down and then up, or something like that. Okay? That makes sense? Because what's in between 0 and 1? Like 1/2, right? So you'd have to do this to 1/2. Okay? So, anyways, compute the difference quotient. Oh gosh. Okay, so difference quotient. Remember, difference quotient is this, where you take the function and then a plus h. You evaluate it at that, you subtract it, evaluate it at a, and you divide that by h. Okay, I'm going to need some room. So here, f of a is what I'm going to compute first because it's easiest. I just have to substitute a everywhere I see an x. Okay, now f of a plus h is not as easy. Everywhere I see an x, I have to put a plus h. Okay, then I have to square this. This is going to be 3 times a squared plus 2ah plus h squared. Then I'm going to go ahead and distribute that. So that's going to be positive 2a plus 2h minus 1. Then I have to distribute that 3. So then f of a plus h will be 3a squared plus 6ah plus 3h squared plus 2a plus 2h minus 1. Okay? So now that's what this whole thing is. Now I got to subtract it, so I'm going to put minus, and I'm going to subtract everything from f of a, which is up here. So minus the 3a, okay, and then I have to minus the 2a. So I'm just taking the opposite of each of these terms, the 2a, and then see how that's already a negative, so that's going to be plus 1. Does that make sense?
Ooh, that's a lot.
All over h. Okay, now your first term should cancel and your constant term should cancel. Okay, then negative 2a, that's going to be with this guy.
Wait, what's canceling?
See how this is a positive one? Well, that's a negative one. This is a positive 3a squared.
So all those terms should cancel.
Mm-hmm. Okay, and so then I'm left with 6ah plus 3h squared plus 2h divided by h. You guys see how everything on top has a h? Yeah? So I could factor out an h, or basically just divide an h by everything. And then I'm left with 6a plus 3h plus 2.
Plus.
Okay? Ugly. But there it is. Okay, 42, it says find the amplitude. That's easy. So amplitude is just the absolute value of this, so it's going to be 2. Find the period. The period is the b term, so the b term is 3. You guys see that? So 3 over, it's cosine, so it's 2 pi. So period is going to be 2 pi over 3. And then here it says find the phase shift. Now check out this. Phase shift is c over b. Now if I was to distribute this 3 to where it's 3x, and then this is going to be, what's 3 over 6? Isn't that 1/2?
So you distribute,
Right.
you got the distribution 3 to both?
Yeah, well that's what distributive property is all about, right?
Okay.
So then that's going to be pi over 2. Pi over 2. So if you're to go c over b, that means that you'd have to go c, this is your c, and then over b means like this. Okay, so then you're going to divide.
So pi over 2 over 3?
Well, hold on, no, check this out, watch. So multiplying, and then that's going to be 1 over 3, so that equals pi over 6. You see that? So that's going to be the phase shift. Now, do you guys see how the 3 was factored out? Well, do you see the pi over 6? So whenever they factor this out, the c over b is already done for you. Okay, so it's right here.
Great.
Okay, so there's that, there's that, and there's that. You don't have to graph this one, so thank the Lord. Okay, now the next one, it says factor completely. Almost done. Factor completely. This is an x cubed, so that means since it's x cubed, we're going to have to use the p over q. So factors of 4 are 1, 2, and 4. So why don't we try, I don't know, what should we try?
What does it mean by factor completely? Because it can't be factor. It wants to find the factors.
Find as much, factor it as much as possible.
Oh.
So, like, let's try maybe 1 or something.
No, it's not 1.
It's not 1? Do we try 2?
2.
Okay, let's try 2. So the 1 comes down. This is going to be 2. That's 2. That's 4. That's 2. And that's, well, no, that doesn't work then.
Yes, it
What
does.
about -2? No.
Wait, did I do so? I didn't do anything wrong.
No, you're
Let's
right.
try negative 2.
It's negative 2.
Negative 2, that's 1, so this could be this, this could be this. Then that means that's going to be a positive 4. Good, and that becomes a negative 4. There's our 0. Okay. So that means that one of the factors is going to be x. I take the opposite here, so it's going to be x plus 2. And then the rest of it looks like this. X squared minus 2x plus 2. Okay, now can we factor that? Are there factors of 2 that would give us negative 2?
Yes.
Okay, what are they?
Negative. Wait.
Yeah. So I don't think that could be factored any further, so you would just leave it like that. Okay. All right. Continuing on. Factor, multiply, and simplify. Now the good news, again, is that it's telling you what you have to do here. Okay, it's giving you the insight on how you're going to clean this one up. So I'm going to make this a little bit thinner. Now this is the difference of 2 squares, so this is x plus 2, x minus 2. And then down here, factors of 12, that would give me 1, are x plus 4 and x minus 3. Over here, difference of 2 squares, so that's x plus 4, x minus 4. Down here, factors of 8, that would give me 2, are x minus 4, x plus 2. Okay? Factoring, just basically using the x and all the techniques that we've learned. Then you divide out everything that is a common factor. So like nothing that's across like up top, but it can be down below, right? It has to be 1 on top, 1 down below. Okay? So I see a positive 4, negative 4, and negative 4, positive 2, positive 2. So what we're left with is basically right here. So x minus 2 over x minus 3. Okay, on a roll. All right, graphing number 45. All right, so in order to graph secant, I need to be able to graph cosine, because whenever I graph cosine, cosine normally looks like this. Secant is going to be at the maximum and minimum points of cosine. So it's going to be a parabola that goes up like this, parabola that goes down like this, and a parabola that goes like this. Okay, the blue is the secant, and anywhere that cosine was 0, that becomes an asymptote that the parabola is just right along. Okay, so before I graph the secant, I'm going to graph this. Okay, I'm going to graph the cosine of this graph.
Wait, okay, the cosine is the one in red, right?
Yeah. Okay, and I should zoom out a little bit. And go like this. Alright, so cosine, I know normally goes up to 1. Okay, 1 and -1, that's the amplitude, but the amplitude here is going to be 1/3. Okay, so it's going to be a tiny thing. It's going to be like a little 1/3 in between this little range of 1/3 and -1/3. Okay, now the period is 2 pi over the b, and our b term is 2. So what's 2 pi divided by 2? Just pi. That means instead of doing a normal like 2 pi range, it's at pi. Okay, so I cut it into quarters. And normal cosine starts here, goes down, goes like this, goes like this, and goes like this. Now, this isn't the graph, but I'm just giving you an example of what's going on. So that's what this kind of looks like without the phase shift. Okay, the phase shift is I need to go to c over b, which in this case is going to be pi over 2. That means I got to move this full party over 90 degrees, or pi over 2. So if this is pi, that means pi over 2 goes right here, right? So pi over 2 in our graph is going to be 2 little graph tick marks, okay? Does that kind of make sense? Okay, so watch what I do here, and I can zoom in a hair so you guys understand. So I'm going to take this point and I'm going to move it to pi over 2 because I have to shift it over pi over 2. Okay, because that's my phase shift. So that's this point. Now this point I need to shift it over pi over 2. Now this point I have to shift it over pi over 2. At this point I have to shift it over pi over 2. That point should be back here. Sorry. This point I have to shift it right here, and then this point I have to shift it over here, and then this point I have to shift it over here. Okay, so this is the cosine graph. Okay, that's what the cosine graph looks like. That's what we just graphed right here. Now to graph the secant, all we're going to do is put the asymptotes at 0. Okay, and then do the parabolas at the maximum and minimum point. Okay, so that's one cycle. Now on the test it's probably going to be finished up like that, you know. It'll go all the way, and then this one.
Where did you put the dotted lines?
The dotted lines are wherever the cosine was at 0, wherever it crosses the x-axis on the cosine. Okay, because remember secant is 1 over the cosine. So if cosine is 0, that means that we have an undefined part. All right, last one. All right, so it says solve the inequality. So in order to solve the inequality, you want to get the inequality by itself. Alright, so first I'm going to subtract 8, and then I'm going to divide by 2 eventually. Divide both sides by 2. So here's my inequality. Now, remember, if the mouth faces the door, that means that it's an OR, right? So here, I'm going to rewrite it, and I taught you guys the method where we just do the copy and paste, but for me, I'm just going to rewrite it. And then remember, you switch the inequality and then take the opposite of this one like this. Okay? And then you just solve. Add 4 to both sides. So that's x is greater than 8. And then add 4 to both sides. And so you have x is less than 0. Now if we were to graph this, look something like this. At 0 and then at 8, they're both open. And then this one is less than 0, which is going this way. This one's greater than 8, which is going this way. So notice it's an or, like oars on a boat. And guess what? We're done.
Okay.
Yay.
Guess what? We're not, because I don't